talk about applications of dosing pumps. This topic is a question that we receive many times from our partners, from our customers, and it's really a topic which is very important for us, and that's why we force into this kind of presentation in order to give you some clarity on some applications. Okay. First of all, in many plants there are the use of dosing pumps. Dosing pumps is never the main component in terms of volume in a plant where there are centrifugal pumps, peristaltic pumps, a lot of pumps, but many times it's very important. So why we have to use a dosing pump? Because in many cases we have the need to dose very accurate quantity of liquids, and the quantity of liquid many times depends on external parameters like process conditions. So there is some parameters that change in the time, and the liquid to be injected for that application also has to change into the time. There are three points very important in this kind of applications, which are, first of all, safety. All the pumps needs to be safe, and in the last years especially they need to save the environment. So that's why the use of diaphragm dosing pumps is very often present in a plant. Accuracy and reliability means that the pumps used needs to work for many years with no problems, and the accuracy, because the accuracy of dosing is one of the parameters very important for that. You have here some examples of the main important applications for dosing pumps and the main market sectors. We will have an overview of many of them and more than this. So for water treatment, power generation, pulp and paper, food and beverage, chemical, oil and gas, and many others. So in many industrial processes, you will have a need to use dosing pumps. Let me give you a first overview on production of OBL, just to understand which kind of pumps can be used in these applications. We didn't put specifically the type of pumps for every application, because principally the pumps can be used, all the line of pumps can be used in these systems. In OBL we used to have a black line range of pump, which are plunger, mechanical diaphragm, and hydraulic diaphragm, spring return, not API pumps. So very often used in a lot of applications. We call it black line, and we can cover up to 1,400 liters at to 40 bar. On the other side, we have the top line, which is really API 675 pumps compliance, which is a mechanical return mechanism that can reach very high flow rate and pressures. We just wrote 5,000 liters per hour, 400 bar, and it is relevant to just one head. In this application, you may also have different multiple pump heads. We will talk about different applications, and we will give you a brief explanation of the process and where the pumps are applied in this kind of process. So you will find a page when we will see the process overview, and a second page where there is the application for the pumps. So let's start for what is for OBL one of the main markets we serve. Water treatment, of course, also for most of you is one of the main markets. And in water treatment we can find two different main processes. The first process we can find is the water depuration. Okay, what is the depuration of water? It's the treatment of residual water from sewage systems with the aim to reduce the pollution load. This is the first phase of every industrial water treatment plant. And after that, to have the water drinkable in many other plants, there is a treatment that is called potabilization. Okay, What is used this? It's used to create water drinkable, okay? When we talk about industrial water treatment and depuration, this is a scheme of what is usually an industrial water treatment plant, where you can find different phases. First of all, the water comes into the plant and shall be treated in terms of separation of solid parts from liquid parts. The first two phases are scrubbing and sand removal. When the solid parts are removed, they need to also remove oil and fat, so the dirt part of the water. Using some processes like sedimentation, oxidation, and mud concentration, you will be able to reduce all the wastes from the waters and to keep it clear. After that, it's very, very important to have biological treatments to remove all the bacteria from the waters, to keep the water suitable to be sent to rivers, to lakes, and to be, or in some cases, to be reused in the plant. In the depuration phase, we can find a lot of application for pumps. What is called primary treatment, it's the first part of the treatment of the water, when there is the need to adjust the pH of the water. So sometimes the water is acid, sometimes the water is basic. So when you dose liquids like hydrochloric acid, caustic soda, or ferric chloride, you will have the balancing of the pH from acidity or alkalinity. In most of the cases, the pumps are used not with manual adjustment, but with electrical servomotor or Pro Control with our new Black Line Pro system, which is able to get feedback from the plant, from pHmeter, and to adjust automatically the amount of dosing of the liquid. The second part is used to reduce the turbidity of the water and to remove physically the dirt. It is called flocculation, and you see the picture that before the treatment the liquid is like mud. After the treatment, with the dosing of anionic and cationic polyelectrolyte, there is formation of flakes. The flakes collect all the dirt parts and bacteria and send it to the bottom of the tank. In this way, they can be easily removed with the scrubbers and can be easily removed mechanically. When we talk about secondary treatments, it's the part where there is the biological sedimentation. There are again different parts and different sections in this plant. There is the part where we call it neutralization, when there is the need to dose biocides and nutrients. Then you have percolation, sedimentation, and filter pressing. So basically, it's a process of clarification of waters and to reduce the bacteria charge on the water with the specific chemicals studied to treat every kind of bacteria. Usually you again used to dose hydrochloric acid, sodium hypochlorite, very often used for the content of chlorine to make the water inertia, and caustic soda again to balance the acidity and alkalinity of the situation. When we talk about seeded water treatment, the most important treatment is the potabilization. So, for example, from spring waters, they need to treat the water to be useful for the human consumption. Again, you see many different steps in this application. We have a mixing of the water. There is a flocculation and consequently a sedimentation to remove the dirt parts. Then we have chlorination and the purification of water. The water purification, it's required anytime to give to the water the organoleptic properties to be safely used for the human consumption. It's a very, very important process, and usually the pumps are very often used in this part of the system, and most of them are electronic adjustment pumps. The first phase when a pump is used is the pre-disinfection, where there is a real need to dose chlorobioxide for the purification and to keep the disinfection on the water. The second very important phase is the water clarification, when again we need to dose some coagulants, and in this case we talk about aluminum polychloride, where the acronym is PAC, or ferric chloride or polyelectrolytes. All these substances have the possibility to create flakes into the water. Some are anionic, so with a negative charge, and some are cationic with positive charge. They work like the battery, when the positive plug attract the negatives. So the bacteria and the dirt part are attracted electrically, and with these flakes, and can be easily removed when the flakes became big. The flakes can stay on the surface, or the flakes can stay on the bottom of the tank. In this case, can be easily removed. The remaining part is water, very, very clear, so with no turbidity inside. And before the human consumption, there is again the need to dose disinfectant. Sodium hypochlorite is the most common used. Not only, of course, there are many others, but this is the very, very common use, with a percentage of between 10 and 12%. This is the final disinfection of the water. This kind of slide represent again what is the real process for the potabilization of water for the human consumption. You can see here an example of an industrial water treatment plant and the possible use of our pumps, or black line mainly, in this kind of plant. You will see that there are a lot of parts of the plant where the pumps can be used. There is odor control also, there is flocculation, the foamer, again sodium hypochlorite. While the initial part are physical treatment, the last part of the plant are biological treatment in the system. We will give you then this slide so you can easily study the different application of our pumps in the industrial water treatment plant. Again, talking of water, one of the most important plants and widely used and with a real growth in the world in this moment are the desalination plant process, especially in area of the world where there's no fresh water from spring, but in some cases if you scave the ground you just find oil. In this case it's very important to get water from the sea. This process is very, very expensive process. It's very complicated, but it's the only way to get fresh water in some areas, like, for example, Saudi Arabia, but also it's very now famous in Egypt also, and in the Middle East. And this industry is seen as a very, very industry with a very big growth in the next 10 to 15 years. So the seawater desalination plants is used to convert seawater into fresh water. There are different phases in this plant. First of all, there is the seawater intake system with big pumps to get the pumps from the sea. And there are RO. RO means reverse osmosis systems. So the seawater passes through membranes. The membranes are able to have osmosis process, so to keep the salt away from the water. And again, it's a sort of clarification process. Of course, there is the need to recover energy in this system, like cogeneration plant, and of course there is the need to dose chemical into this water to make the water clean. You may understand that this seawater is full of chlorine, sodium chloride, of course, and the material to be used in this application sometimes is like alloy, so precious material and very expensive. This is one of the main reasons why these plants are very expensive. There are also phases to have CIP cleaning, so cleaning in place systems, and all the system is controlled by PLCs. Many of the plants are automatically. Here you can see a scheme of it's a desalination plant with different phases, and dosing pumps here are very important part in the whole plant, especially for these 4 different phases. First of all, there is again a pre-treatment of the water. The water from the sea is many times is very clean, but sometimes it comes from area where it's not so clean and is full of seawater, it's full of dirty. So there is a pre-treatment, which is very common to the pre-treatment in a potabilization water plant. We need to dose coagulants and bactericide to lower the charge of vectors. In reverse osmosis, there is a big need to dose antiscalant to avoid the formation of scaling before the first level of reverse osmosis. In the second level of reverse osmosis that you see in the scheme, the need is to adjust the pH. So as you may understand, there is also, again, the need to have caustic soda or acid adjustment. The last part is the boiler feed water that we will see later in another slide, because here there is again big boilers to warm the waters before the treatment. Again, this is a scheme. It seems very simple, but these plants are sometimes very big, and the amount of water treated is very big. So here the pumps can be black line, but can be also top line due to the flow rate, which can become very big. Power plants, very big application, especially in Egypt. We have a lot of pumps installed there. What is a power plant? Simply, power plant is an industrial plant used to produce electricity in many different ways. But in every power plant there is a huge generation of hot water, and hot water needs to be cooled down. With what? With the use of evaporative towers. If you see a power plant, you will see a big column of white smoke. This is nothing else than water vapor. The working of evaporative tower is to chill the total amount of water with a technology that uses just a small quantity of the same. You may understand that if the water is not totally clean, there will be a lot of formation of deposits on piping. There is a problem of salinity increase due to the evaporation, minerals, and formation of seaweeds and biofilms. The consequences can be terrible, and the cooling water shall be clean to avoid damages in evaporative towers. You may understand that the cost of this evaporative tower is very big. So how to treat the water for a cooling tower? You can see here again a scheme of the treatment. The water is always very warm and need to be chilled in this system, and we need to keep a low level of cooling into this water. With what? With using antiscalant and corrosion inhibitors. These are chemicals produced by chemical companies with different formulas, but mostly the most important parts are used to keep the scale very low and to avoid any kind of corrosion inside the cooling tower. The formula of the chemical depends on the water to be treated. So there are always a big study from the chemical companies to understand which is the best solution. But again, the need to dose needs to be very, very precise. And there is always an automatic control with sensors put inside the cooling tower that give signal to the pumps to adjust precisely the amount of chemical to be dosed. It's also very important to keep the pH very well balanced. Again, the acid and basic solutions are used. Here, in this way, there is more the use of sulfuric acid, usually at 98%, or caustic soda. Again, there is an automatic control of these parameters through the sensors and to the pump. And at the end, again, commonly with the previous slides, they need to reduce bacteria because this cool water and sometimes is reused into the plant, and many times is sent to rivers, to the sea, and to sent out of the system. So this water needs to respect some parameters given by the local laws in terms of bacteria. And again, the liquid to dose here, hypochlorite, sodium hypochlorite, because the disinfection, but also peracetic acids and biocide. In every plant, again, in the plant you saw before, also there are big boilers. Boilers needs to warm the water to the process using many times the flue gas, and the water that is injected into the boilers need again to be treated. The main important processes here are filtration and ultrafiltration, because we do need to avoid the entrance of any kind of particles into the boiler with mechanical filtration. There is ion exchange, and there is again reverse osmosis with deaeration, degasification. After that, all the chemicals that remain into the waters need to be removed with the coagulation and chemical precipitation. Where the pumps are applied in these boilers, again, for the feed waters, for chemical precipitation, we again inject some liquids such as aluminum polychloride, ferric chloride, and here we have again the pH adjustment. So you see that many times in many processes there are the same application when we talk about waters. Even if we talk about boilers, we are still talking about water treatment in the boilers. So you will see the same liquids like polyaluminum polychloride, ferric chloride, caustic soda, acid, and so on. For the reverse osmosis, it's important to have the resin regeneration, because the reverse osmosis plant is made by big columns with membranes where the liquid, the water pass through, and this membrane needs to be regenerated time by time with the resins. And the regeneration is made by dosing of hydrochloric acid and sulfuric acid. It's sort of cleaning of these membranes. At the end, after the softening process, some boilers feed water need to be utilized with dealkalization to reduce alkalinity and pH. And again, you see sodium hypochlorite, but also sodium carbonate, nitrates, amine, phosphates. In the past, it was very, very useful to use hydrazine, but now I think it's forbidden by the law due to the possibility to create cancer. Phosphates are very, very often used in this process. So the process of the boiler feed water, it's very complicated, but the most important part is dealkylization. So where you will see pumps used, especially in chemical injection packages, to inject these amine, phosphate, nitrates, and carbonate, sodium carbonate. Okay, now we turn into some other fields. We can talk now about oil and gas. Oil and gas is divided in different parts. Where we call upstream, it's the extraction of the oil and gas from deposits. Deposits are under the ground, can be onshore when we talk about deposit into the earth, or offshore when the deposit is below the sea level. The pressure where we inject depends on the depth of the oil formation. Of course, how to remove the oil from the ground. You see in this picture that it's the oil is represented like a big lake, but many times it's not like that. The oil is inside the stones. It's inside very small particles. So you need to inject high pressure liquid or methanol to keep the oil going out from the well. In fact, in the oil and gas upstream, dosing pumps, but also process pumps here, we talk about big flow rates, are used to inject methanol. So we inject methanol to have a well balancing, oil well balancing. So injecting methanol, you create an overpressure and the oil go up. When you have a well, you will put big pipe to the ground, but this piping needs to be again treated with wax inhibitor to avoid formation of wax, to injection of anti-scaling to avoid scaling, anti-foam to avoid foam, and corrosion inhibitors. The quantity, the amount, the type of this kind of liquids depends on the quality of the oil or the gas you have to extract. So again, here there is a big job made by chemical producer to check the right amount of liquid and to check the right quality. Okay. Chemicals producers are very important in these wells, but also they give us the pump producer information about the kind of pump we need to use, what is the viscosity of the liquid, what is the chemical contents, so we can select the right material for the dosing pump. After the oil is extracted, the oil and the gas goes to the refineries. This part of the oil and gas is called downstream. In a refineries, we can find 3 or 4 different phases. What you see here is the main important is the distillation phase, which is clearly a process that involves the separation of material, which is based on different volatility. Again, you will see a boiler here, you will see a lot of things that you saw before. There is cracking, where the oil is divided into different particles due to their different weight to create hydrocarbons. When hydrocarbon is created, in the bottom you will get the very heavy like asphaltene or oil, then you have kerosene, naphtha, and gasoline is in the top and gas is on the top because it's very volatile. All these liquids and fluid can be treated with, again, chemicals to have the right properties of the liquid you want to have. Again, we can find here primary treatments. So during the distillation, it's very important to remove water from oil. As I said before, when you extract the oil is not so pure. So you will find dirty, you will find mainly you will find water, and the water is very dangerous in a refinery. So how to remove water from the oil? With the use of glycol. Glycol has a big power to absorb the oil, so the oil goes through the glycol, and the glycol is injected countercurrently to the fluid velocity. In cracking and in transfer also there are a lot of pumps, dosing pumps especially, where you have to dose the emulsion breaker so that the oil is very well separated from other substances. It's like a physical treatment. In the transfers also, when you transfer the liquid into pipelines, you have the same problems to avoid corrosion. So, for example, with those chemicals for the salting, with those sludge inhibitors for the fuel oils, with those metal antioxidants, and caustic soda to adjust the pH of sour gas to prevent again corrosion. So you again see many treatments that are very common to other fields, but the liquid dosage is changing every time. In the downstream refinery also you have secondary treatments when the liquid is moving to the pipeline, it's very important to avoid corrosion, scaling, foaming. So you will use corrosion inhibitor, anti-scaling, anti-foaming. You see here an example of the pump very often used, our X9 pump, double diaphragm pumps, which belongs to API Petroleum American Institute 675. So in refineries, oil and gas, it's mandatory to use API 675 pumps. In a refinery also you will find water treatment, because again there is water to use, and the same treatment that we found before can be used in this field. Also here you have water treatment. All water needs to be treated, specifically to remove sulfur. So sulfur is very dangerous for the health. It's present into the gas, it's present in the oil, so it's put it down with the water, and the water needs to be treated. The most common liquid used is oxygen peroxide. But in this plant there are also evaporative towers, but are also cooling towers. So again, you will see the same treatment that we saw before in the cooling tower plants. Petrochemical plants. Petrochemical plants use again as raw material, they use gas or hydrocarbons coming from refineries. So petrochemical comes in the line after the refineries. And the obtained products starting from these raw material as oil and gas are used then as raw material in production of plastic, polymers, and so on. Petrochemical complex, I think that if everyone have never been inside one plant, is very complicated. There's a lot of piping, there is a lot of instruments, a lot of pumps, because it's a process which is very complicated and which involves many technologies. Again, we can find a lot of additives, those mainly through chemical injection packages, not simple pumps, to optimize the chemical properties of the liquid. So there are two main applications. One is called main processes, where the additives are used for the petrochemical production. So they have to inject flame retardant, wax inhibitors, lubricants, amine, and a lot of other products used to create the polymers. And again, secondary process, side process, is the dosing of additives for pipeline, such as biocide, anti-scalent, anti-foam, corrosion inhibitor. So again, we see here the same process as we saw before in the refineries to treat the liquid from the pipeline, or to treat the water that is used into the plant. Biodiesel plants is another plant used. It was very famous many years ago, now is a little bit less, but it's a sort of competition of refineries. They used to produce especially diesel from biomass. But biomass needs to be treated, to have a very specific process. And the raw material used are vegetable or animal fats or oil that needs to react with the short chain of alcohols, typically with methanol or ethanol. In the biodiesel plant, we find three different phases. The first, again, is distillation, where we need to add chemicals like here potassium hydroxide during the process. Why? This is needed to ensure that ethanol is pure at 95–97% for this process. The second phase is the fermentation. And again, we need to dose methanol, caustic soda, sulfuric acid to have the pH in a proper level. And the last part, which is the main process of this plant, is the esterification. Again, here we remove the alcohol and we get the biodiesel. And there is a big need of dosing of catalyst, silane, silicone additives to ensure chemical process. So biodiesel plants, it's sometimes very complicated. But again, we can divide the plants into different fields, and we see that the pumps are used mainly for the same liquids. Part of the esterification, when the catalyst, silane, and silicone are used, and that is some liquid that we just find in this kind of plant. We also have applications in pharmaceutical plants. Pharmaceutical that is, of course, very famous in this moment due to the big run to create drugs. There are a lot of different phases that you can see here. It's in batch manufacturing. So there is blending, there is wet granulation, drying, milling, compression, coating. The pharmaceutical manufacturing process has some peculiarity respect to many others, that is the accuracy of the pumps shall be very, very high, because we are talking about recipes of drugs that need to be very, very precise. Pumps are used in two main different applications. Are used to transfer chemical solution from one reactor to the other, passing through metal clarification column. So they pass through some plates where the metal is attracted and removed from the liquid. Why we use those in pumps here? We use those in pumps because many times the pressure is very high, and so compared to a centrifugal pumps, because flow rates are not so big, it's a very economic solution in these fields. But also those in pumps are very often used to inject specific additives into the drug formulas. We many times here don't know the real liquid that we dose, because like Coca-Cola, they have secrets. Also pharmaceutical plants have very, very big secrets in their recipes. So they say as dosing pumps need to be suitable for stainless steel and so on. Now we go through other fields of application that where we can find pumps. One of the most important application, especially in South America, it's mining industries. Mining industry is an industry where it's a lot of material are extracted in very, very precious, sometimes like gold, copper, magnesium, bauxite. So where the pumps can be used here, many applications, more than what you think. Those pumps are used to dose chemicals to clean the extracted materials. Again, the gold is not extracted as pure gold. It's inside some other stones, and you need to remove the other parts, not damaging the specific material. The most common acids are hydrochloric acid and sulfuric acids. But because you use a lot of water, also again here there is a residual water to treat it, especially to remove stones and mud. So coagulants are often used. Ferric chloride and polyelectrolyte are the most common applications. We have other big application in ceramic industry, another plant, but the process is starting from the extraction for minings, bauxite, for example, aluminium. There is a mixing of raw material, aluminium, zinc, clay, shredding of raw material, and then atomization to create power that then is pressed, cooked, and make the tiles. That is the process of ceramic industry. Where the pumps are used, during the shredding phase, there are mills, and the mills take a lot of powder, so they need to inject a lot of additives to create some fluidity in the liquid to be then transferred easily. Again, we don't know the formula that they use to do this kind of pumps, and sometimes the pumps are automatically because the dosing depends on the speed of the mills. The application here is terrible in terms that the environment. It's full of powder, it's full of, if you see a black line after 2 hours, it's a gray line or brown line because it's totally full of powder. Another industry where there are a lot of dosing pumps, some of them are solenoids, but many of them are motor-driven pumps, is the paper production. Okay, how we can make paper? Paper usually is created using the raw material as waste paper that is reduced in small pieces to create the cellulose. Then the paper is pressed. There are formation of sheets passing through again layers, and there is two processes, which is whitening, and then there is packing and transport. Again, where the pumps are used in different phases. First of all, there is the first phase is where the maceration of the paper. So the waste paper is sent to the big tanks, and we need to inject caustic soda. Caustic soda helps the destruction of paper fibers. In the phase of whitening, so you see the waste paper is not white, of course, it's full of colors. They need to create white paper. So they use oxygen peroxide, caustic soda, but also formaldehyde and sodium silicate. During the paper sheet formation, there are again various chemicals provided by chemical companies. There is the lightening, the waterproofing additives, and the tightener. So a lot of components to be added to the paper to create what then we used to write. So if there were not this kind of treatment, the water can go inside the paper, so it's not waterproof. And when you write down, it's very, very soft. In this plant also there is a big use of water. So again, we have an industrial water treatment plant, which is common to most of these kinds. And the most common used liquids are caustic soda and polyelectrolyte, because there are a lot of formation of dirt there. We have some other very nice application for the enology industry. There is wine and beer filtration. And the filtration is a process that can be used different time in the transformation of wine after the fermentation. Because after the fermentation, inside the wine, you still have nitrogen nutrients, you have yeasts, and you need to separate them from the wine. You need also to eliminate the precipitation after the refrigeration to get a very bright and sterilized effect before the bottling. Filtration creates something that is very clear in keeping all the characteristics. So it's important to dose some liquids that is inertial and don't have any effect on the quality of the wine or the beer. We have a specific pump that is called H series that can be plunger or diaphragm pumps that is installed on tanks, because the filtration in this case is made by diatomite, which is a fossil created from the stone, so it's a natural product where the liquid of the wine pass through and is not affected in terms of quality. So this liquid, it's not mixed totally, but it's a solution and needs to be mixed every time. This pump you see as a shaft. On this shaft is put on the tank, and the tank itself as a mixer. So contemporary you have dosing of the liquid and mixing of the tank. It's a very, very nice application, and we sell a lot of pumps to producer of plants to make the wine. We have some of them in Italy, but there are also other in many, many parts of the world. We also have application in textile industries, and dosing pumps are used to two different applications. One is to inject colors, the tissues and need to be colored. And we have a lot of application when the pumps are automatically, because it depends on the velocity of the system. But also there is the injection of resins for the production of synthetic fibers. The water treatment plant is also present here because we need to treat residual waters. Again, there is a common in every plant. And again, we need to dose polyelectrolyte, to dose acids, additives. If you ever been into some textile, you maybe remember the smell, the bad smell. Because the liquid are very chemical, there are a lot of chemicals inside, and the waters needs really to be treated many times. We also sell pumps to food industries. Even if our pumps are not yet FDA compatible, but have all material FDA approved. So the pumps can be used in every process where there is no strict requirement from FDA. Or the pumps are used before the sterilizations. For your information, at the end of this year, like October, November, we will have a certification used in Europe that is a sort of FDA that can make our pumps suitable for the food industry. The main application here is the transfer of additives for milk and yogurts, dosing of additives for candies and chocolate with flavoring, but also transfers of tomato sauce of broth nut. In these plants also there is a big need to clean the system. So the dosing pumps are used in part of the plant called CIP, cleaning in place, when you dose usually citric acid and caustic soda to clean the piping, to clean the stainless steel, and all the plants is made in stainless steel points. Another couple of applications where the pumps can be used: fertigation. In the past, this was not so important, but at the moment, due to the increase of productivity, there needs to inject fertilizers daily. The pumps are used, especially in Europe, for 1 month, 2 months, maybe in the tropical area more than the period. And in the past, they were not used to have very high quality pumps. In this moment, they are coming to OBL to get some high quality pumps because they don't want to change the pump every year. So the pumps are sold and sent to the fields, stay under the every kind of water conditions, and are used to inject fertilizers daily to improve the production. Also, there are a lot of biological treatments to avoid damages from bacteria and insects into the plantations. We used to sell pumps also in cattle breeding for odor control and water treatment. And again, we can have here automatic pumps with Pro Control to treat these residual water treatments and to treat the odor, so odor control. Methanol is also injected. So this was the last slide for the application and how to select the right OBL pumps. You go to the Compass, you go to the website, download your Compass. It's a navigator where you can find a lot of liquids and a lot of application, and you can get these kind of applications and liquids that I mentioned before. I hope it was enough clear, not too much boring. So if you have any question, please go ahead. And thank you for your attention.
Yes, hi David, this is Yahya.
Hi.
How are you?
I'm fine, thank you.
Hope you all safe and good.
Yes, luckily yes. Working by home, okay, but it's okay.
Yeah, okay, wish you all the best. No, actually my question here just, I didn't see any really much details about the food industry.
Yeah.
Which is related that you still don't have an approved FDA pumps. That's the reason, or?
Mainly our pumps are used in many industries, food industries, before the sterilization. We don't have pumps FDA approved, but we have FDA compatible. So when they ask us to go into the main process after sterilization, we don't have the right pumps, and it was a choice to don't go in this field where there are a lot of other companies. But in any case, we found that we have a lot of applications. So, for example, we give pumps to Perfetti, production of candies. We give pumps to milk factories in a lot of applications. And maybe this is one of the fields we have to investigate a little bit more. And as I said before, at the end of this year, we'll get the MOCA certification, which is a sort of FDA for European regulation that is very often required now, especially in the North Sea countries in Europe. Still, we need a couple of months of work, and then the certification is done. It's not the FDA, but it's very similar to FDA, so it's accepted. So at the moment, this is the right reason why we don't get too much into that field.
Mm-hmm. Yeah, because I think in our region there is a big potential for this. You know, there are big companies for dairy companies that they produce the milk or dairy products. So there are big companies in the region here. One of them, maybe Al Marai in Saudi Arabia.
Yeah.
And in UAE also there are a couple of big companies as well. So
anyway, for the milk factory, I can assure you that we already sell a lot of pumps. So maybe you can investigate our pumps. It's enough. Again, our FDA, not FDA, but if FDA is not strictly required, we can give a certification that all material in contact is stainless steel and PTFE, which is totally compatible with liquid. The problem of the FDA is that when you use it in the process, so the liquid is not then sterilized, you need to avoid any corner, any part where the liquid dose can be stuck and can create bacteria. That's a real problem. Why you use clamp connection and not using piping with corners, but just bands.
Yeah. Okay, fine. Thank you. It was an interesting presentation. All the best. Thank you.
Thank you. Some other question? So if there is no other question, you will get this presentation and you will get the link to download the presentation, the video for your register. In any case, you may have any other question in the future, don't hesitate to call us and give us your question. For your further information, you will receive a survey questionnaire in the next hours, which we kindly ask you to fill it and send it back. It's totally anonymous, just to have a feedback on your presentation in order to improve our academy in the best way as possible in the futures. Thanks again to everybody, and see you to the next webinar.
Thank you.